So guys, you can see this is our transmitter PIC, that is the receiver PIC over there, this one. This PIC has the button. This button is connected to this PIC, while this LED is connected to the receiver PIC. Now whenever I press this button, see, the LED turns on. See, I press the button, LED is on. I press the button, LED on. LED on. LED remains on for 100 milliseconds, then turns off. What happens is that whenever I press this button, a character A from this PIC goes to that PIC over the UART port, and that PIC is programmed in such a way that it will receive the character and then it will check. If it's A, then it turns on the LED, else the LED remains off. So let me show you the code. So guys, this is the code for our receiver PIC. See, we just took a char variable to read the character coming from the other PIC. We initialize the LED, we initialize the UART port with 9600 baud rate. We check whatever the data is coming over the UART port and we store it in the rec1 variable. Then we check if the rec1 variable is A, then turn on the LED and keep it on for 100 milliseconds, else it off. Then this is our transmitter PIC. In the transmitter PIC, we just initialize the button. We initialize the UART port with the same baud rate as for the receiver PIC 9600. Then we checked if the button is pressed. And if the button is still pressed after 50 millisecond delay, only then it is considered to be pressed and a character A is sent over the UART port after checking if the TX buffer is idle. Else it sends the character Z. So see, only a character A is sent whenever the button is pressed, else a Z is sent because our receiver PIC is programmed in a way that it only turns on the LED whenever a character A is received. If any character like Z, B, C, D is received, it will not turn on the LED. So this is very simple code. So this is our hardware connections. Two PICs connected together over the UART port. LED is connected to one PIC, button is connected to the other PIC. Whenever the button is pressed, the LED turns on. So this all gives us this result. See over here, we are having a UART based communication. Guys, welcome to learning microcontrollers. In this video, I will show you how we can interface a PIC16F877A microcontroller to another PIC16F877A microcontroller using a UART board. So we will be doing UART communication between two PICs, and in this tutorial I will be using a push button on one PIC and an LED on the other PIC. Then we will use this push button to turn on the LED on the other PIC. So let me show you the circuit. That's very simple. So guys, this over here is our first PIC, PIC16F877A having 40 pins. It's a DIP version. This is the second PIC, PIC16F877A, a DIP version. Then let's do the connection. Since we are using a UART port and the pin number C6, that is pin number 25 of the one PIC, is the TX pin, while the pin number 26 of the PIC, that is pin number C7, is the RX pin. So TX will go to the RX, or the RX will go to the TX, vice versa. And then for the second pin, that is the RX pin 26, will go to the TX like this. So TX of the one PIC's UART port will go to the RX of the other PIC's UART port, and the RX of the one PIC's UART port will go to the TX of the other PIC's UART port. So TX to RX, RX to TX, simple. Now guys, these two pins are required for the UART communication. Then the third pin is the ground pin. Just common the ground of both the circuit like this. Now in this circuit, as I have already told you, we will be having a push button and an LED. So this is our 5mm crystal type LED having two pins, one longer, one shorter. And then to connect this with the PIC, we need a safety resistor. This resistor makes sure that our LED do not get burned. So it can be of any value. The higher the value of the resistor, the dimmer the LED will glow. So I will take it to be 220 ohm. That's an ideal value. So the shorter pin of this LED is the ground pin, while the longer pin is the power pin. So you can connect the ground pin directly with the common ground of both the circuits like this. And for the longer pin, you connect the power pin of your LED to the one end of the 220 ohm resistor like this. From the other end, you can use any available digital input output pin. I will use pin number B0 of the second PIC. So this is the second and this is the first PIC. Or we may call this is the PIC, the receiving PIC, receiver PIC, and this is the transmitter PIC. We will connect the button now on this PIC. Now this is a push button, a tactile tick-tick push button having two pins. I call the left one as signal, the right one as a positive. Now guys, the thing is these pins can be shuffled. It's not a polar component. You can shuffle these two pins as well, doesn't matter. Okay, now to connect this with a PIC, you need a 10K resistor. This resistor will decide either your PIC sends a, whenever the button is pressed, a 1 is sent or a 0 is sent by the push button. So Let me show you. I will connect this button in such a way that whenever it is pressed, a 1 will be sent. So the positive, you just connect it directly to the VCC pin of your PIC like this. You give like 5 volt to this. For the other pin, that is the signal pin, you connect it to the one end of the 10K resistor like this. From the other end of this 10K resistor, you send it to the common ground. Now from the first end, where we connected the signal pin, you will take out your output. For the output, you may use any available GPIO pin. I'm going to use the pin number B5 of the transmitter PIC. So this is a transmitter PIC, this is the receiver PIC, like this. Now in this way, our button is connected in a way that whenever it is pressed, a 1 will be sent. Now a very good indication of knowing either the button will send a 1 or a 0 is that take a look at the 10K resistor. If its one end is at the grounding end, it means that a 1 will be sent. So that's a simple indication. Now guys, we have our LED connected, we have the push button connected. Now what we will do is that we will program these both PICs in such a way that whenever this button is pressed, a signal will be read by this PIC over the pin number B5, and as soon as the signal is picked, we will program it in such a way that it will send A, or any character A, B, C, D, or I say a character A over the UART port to this PIC. And we will program this PIC in such a way that it will check the UART receive buffer, that if character A is received, then it will turn on the LED. And for how long we want the LED to be on, we will just set the delay over there. So this will be our simple program to demonstrate to you the UART communication between two PICs. So let me introduce you to the hardware, then we move on to the programming. So guys, this over here is our hardware, very simple. Now this one is the first PIC. This is the second PIC. Now we will indicate one as a transmitter PIC and one as a receiver PIC. Now this PIC is on which my button is connected. Now this is a button, you can see. This button is connected to this PIC. So this is the transmitter PIC, and this LED, there is the LED, this one, it is connected to that PIC. So that is the receiver PIC. So transmitter PIC and the receiver PIC. Simple hardware. Now let's go to our programming. I go to the micro C4 PIC. So guys, this is the micro C4 PIC. Let me zoom in. So click on File, New Project. This window pops up. Now I also have a video lecture on this, how to download and install this micro C4 PIC. You can just go through that to see how to do it if you don't have the software. Then click on Next, write the name of the code. So first of all, we are gonna program the PIC having the button. So we call it the TX PIC button 1. Okay, this is the code. Okay, you should be small. TX PIC and X should be small. So this is the name I wrote. Here you select the path where your hex file and the C files will be created. Here you select the device. I have the PIC16F877A. Here you select the crystal. The crystal connected to the pin number 13 and 14 of my TX PIC is 16 megahertz. Click on Next and finish. Now wait. Okay, here you go. Before you do anything else, first of all, click on File and save your work. Now save it wherever you prefer. I just save it in the default folder. Okay, there we go. Now first of all, we know that we have a button connected to the pin number B5. So we initialize the button pin. I write tris B.F5 equals to 1. Now this is the button pin. And now remember, tris is the register which defines the direction of the pin in the micro C. B is the port name. F5, this means the pin number 5, B5. And whenever you write 1, it means the pin has been declared as an input. If it is 0, it means the pin has been declared as an output. So in our case, since the button is an input device, so we will write 1. So the pin has to be declared as input. Now guys, we give the initial state to this button pin. Like initially, what should be the default state? I write port B.F5 equals to 0. Why 0? Because I told you that we have connected this button in such a way that whenever it is pressed, a 1 will be sent. So if the 1 is sent, then our loop is executed. So what we did, we set it to the opposite, that is 0. That by default it is 0. If it is pressed only, then it will be 1. And when it's 1, then we will do certain operations using the button press sequence. Now we give some initialization delay, not necessary, but I always suggest you give it in the one-time loop. Now guys, here we go. The button is initialized. Now we also have the UART port connected to the other PIC. So we go to the right. Here you have these micro E libraries expanded. Then you have system libraries expanded. Go down, there you have the UART, check mark this, expand it. There you have this UART1 INIT, double click on it. This window pops up, go to the example. There you have this command UART1 INIT 9600, go back, paste it in the one-time loop like this. Now guys, this is the command to initialize the UART port with our desired baud rate. The baud rate by default is 9600. I am okay with that. So once you, but remember that whatever the baud rate you set for the transmitter PIC, you have to set the same for the receiver side as well, as the receiver side will not work. Again, give some initialization delay. Again, not necessary, but I always suggest you give it in the one-time loop. Now we can go for the forever loop because we have our button initialized. We also have the UART port initialized, and we don't have any other component. So we can go for the forever loop, right? While one forever loop starts here, ends here. Now guys, inside it, we will do our programming. Now, as you know, first of all, we need to check if the button is pressed. If port B.F5 double equals to 1. Suppose if the button is pressed, then again check if the button is pressed or not. I will tell you why. Check again. Now, if the button is pressed and we add some delay and it is being pressed for like 50 milliseconds, only then consider it to be pressed. And now the ending bracket for the inner loop, the outer loop. Now, remember what I am doing here is that if the button is pressed, then wait for 50 milliseconds. If still it is pressed, only then consider it to be pressed. This is called debouncing delay. Suppose your button gets pressed by unknown phenomena like some electrostatic shock or anything, then that will initiate the sequence and your LED will start to blink randomly on the other PIC. To overcome this problem, we use a debouncing delay. So this is very useful. Now inside it, if the button is pressed, now we will not blink the LED, we go to the right. We send a character to the other PIC, like please blink the LED. So you look for this command UART1 TX idle, double click. This is the command, you copy this whole loop, go back, paste it like this. Now this command, if UART TX idle double equal to 1, make sure that if your transmitter buffer is ready, only then write the data. Now what we should write? We should write A, write A, character A like this. Now if first of all, we will check if the button is pressed. We wait. If the button is still pressed after 50 milliseconds, then we write the character A using this command. Now, for the safety, like we do not get a rag back value, we have used this if UART TX idle double equal to 1, UART1 write A. So this is only checking if the TX buffer is idle. Then if the buffer is idle, it will write the character A only when the button is pressed. So this is what we just did here. And to make sure that we do not like, okay, this will be fine. Okay, this is fine. Now these are the 3 loops, leave them. Now else if the button is not pressed, in other case, otherwise, or if the button, then just copy this loop, paste it here, send anything other than A, because if you still get the A, the button, your LED on the other PIC will remain on. So anything other than A will make sure that your LED do not turn on. So you may send Z, X, B, Z, whatever you prefer. So this is a simple code. Like if a button is pressed, A will be sent to the other PIC over the UART port. And if the button is not pressed, we will be getting Z. So now we can do the programming for the other PIC. So I built this code, built successfully, no error. We also write this code, then we write the code for the other PIC. So there is the PIC3 programmer tool. I also have a lecture on this, how to download and install this. You can go through that. Click on tools, check communication first. Okay, it is detecting PIC3. Okay, found. Click on file, import hex file. This is the file we just created. I click on write. Okay, the new file is being written. We wait. Let me show you the hardware. Okay, it is writing the new file. Programming device, program. Wait. Okay, this is the transmitter side PIC we are programming first. Okay, done. Now that's perfect, and we have powered up the circuit using the PIC3. I'm powering up both the board using my PIC3. Okay, there is the button. Now see, if I press this button, the LED do not turn on because the receiver PIC is not programmed right now. This is the LED. So now we go and program the receiver PIC as well. So we also change the position of our PIC3 to the receiver side because we have to now program that. Here you go. Now it's the receiver side. So I again go to the micro C4 PIC, zoom in, go to the left again, click on file, new project. This window again pops up, click on next. and instead of TX just make it RX PIC button. Okay, that's perfect. Okay, this is the path where your files will be created. Select the microcontroller. I have PIC16F877A. The receiver side PIC board, on that board I have a 20 megahertz crystal connected to pin number 13 and 14 of the receiver PIC. So I will select 20 here because it's the 20 megahertz external crystal connected to that. Click on next and finish. Okay, click on file and save your work before you do anything else. Okay, that's perfect. Now guys, we do the programming for the receiver PIC. On the receiver side, we have an LED as shown in the presentation connected to pin number B0. So we program that first. So I write here trace B.F0 equals to 0. Now see the effect. For the button interface, for that pin, we use 1 because 1 means if you give a 1 to the trace register, it means that pin has been declared as input. So in case of LED, we always want the pin to be declared as output. So we are giving it a state of 0. Now initially by default, I want the LED to be off. Port B.F0 equals to 0. So by default, the LED will be off. We give some initialization delay. I give an initialization delay of 10 milliseconds. Now we initialize our UART port. Again, go to the right. Micro libraries expanded, system libraries expanded, go down. There you have this UART, check mark this. And here you have this UART1 INIT command, double click on it. In the example here, there you have this command, copy it, go back, paste it in the one-time loop like this. Now by default, the baud rate is 9600. So we are initializing the UART port of our receiver PIC with a baud rate of 9600 because for the transmitter PIC as well, the baud rate was 9600. So same will be required. We give some initialization delay. Again, not necessary, but I always suggest you give it in the one-time loop. Okay, now we have our LED initialized for the receiver PIC. We also have the port UART port initialized. Now we go for the forever loop. I write while 1, forever loop starting here and ending here. Now in the forever loop, first of all, what we have to do is that we have to read the data coming from the other PIC. So for that, go to the right. Here you have this library, UART library. There you have this UART1 read. Double click on this command. There you have this whole command structure. Copy it, go back, paste it in the one-time loop. Now, forever loop. Now guys, this command, if UART1 data ready double equal to 1, this command checks the receiver buffer of the UART port. If it is ready, only then it will read the data. Now this is the variable which will read the data coming from the UART pin. And then this is the command to read the data. And this command reads only a char. Only a character can be read using this command. So here we initialize our variable first. I write char, a character variable, any, rec1 will do fine. Then copy this and paste it here. Now rec1 is a char variable which will store the data coming from the UART pin, RX pin in the second PIC. So once the data is read, now we have to check. We check if rec1 is double equal to A, then what it should do. If the rec1 is double equal to A, then it will turn on the LED connected to the port B.F0. Copy this. It is off by default. We turn it on like this. It will be on. And for how long it should remain on? With one button press. Now that is here what we decide. So with the one button press, only one A is sent on the TX side. Then on the receiver side, we decide for how long the LED should be on. Like this will be the blinking speed if we say so. So I want the LED to be on for like 100 milliseconds. So once an A is received, the LED will turn on and it will remain on for 100 milliseconds. Else in case anything else is received other than character A from the other PIC over the UART port, then the LED will remain off like this. So the LED will remain off. So this is a simple code. So let's build this. Build. Let me tell you what we are going to expect from this code. So we have a character variable called receive1. So void main, we initialize the LED, then we initialize the UART port, then we check if whatever we are reading over the UART pin, we are only reading chars, characters. So if the character read is A, then it will turn on the LED for 100 milliseconds, and else the LED will remain off. Simple. So we build it again. Now we go to our Picket3 programmer tool. There we go. Click on File, import hex file. This is the code, RX PIC button. click on write, wait. Okay, it's being written. Let's get to the hardware. Let it write the code. Okay, the code is being written. We have to wait. Wait. Here you go. The code for the second PIC is also written. So now we are powering up both the circuits using the PIC3. So let's see, does it work or not? Okay, till now it's very good. So this is the LED. You can see the LED here. This is the LED, this is the button. I press the button, see the LED turns on, else it's off. I press the button, the LED turns on, else it's off. Let me bring the LED near so you guys can see better. Bring it here. Okay, this is better. Okay, so this is the button. I press it, it turns on, else it's off. Now see, the LED is connected to the other PIC. Now see these two wires, they are going to that PIC, while the button is connected to this PIC. See these three wires, this yellow and red and brown, they are coming from this button. See, now this is connected to this PIC. So we are basically having a UART communication between both the PICs, causing the LED to turn on and off with the click of a button. See, so you can write various codes. This is a very useful technique of interfacing two PICs using a UART port. You may be able to use it in various projects where you need more than one microcontroller. So to expand the application and expand the pins, expand the feature, expand the processing power and other stuff like adding more code to your works. So you will need these techniques. So this is just a demonstration using an LED how you can do it. See, it is working like a charm. So guys, this is it. If you guys have any questions, please do ask. So we'll see you in the next video. Goodbye until then.